Alright, 6.2. In 6.2, we are adding and subtracting rational expressions. So, write my title. What that means, we just talked about what rational expressions are, and we simplified them, and we multiplied them and divided them. Now we're going to add or subtract them. So here's an example. It's a rational expression because it has an x in it in the numerator here. But if I were asked, the denominator has to be the same and it stays the same. And then add the numerators, x plus 7 is 8x. And of course they would probably reduce that, so they would have 4x to the third. How about this one? X squared over x plus 3. Subtract 9 over x plus 3. Clearly rational, x is in the numerator and the denominator, and nicely a common denominator. So I'll just go ahead and write that in my answer. And then I'll do the subtraction in the numerators. So I get x squared subtract 9, which I see is a difference of two perfect squares. So that will factor, won't it? And it will factor to x plus 3 over x minus 3. And then I have one term on the top and one term on the bottom, so I can reduce what they have in common. And my answer is x subtract 3. Now, what if I gave you something like this? We'll use a and b just for the heck of it instead of x and y. You could see anything there. Looking at that problem, I can clearly see they don't have a common denominator. But if I multiplied this by 2 and by one more a, they would have a common denominator. So this is how I like to do these, and this is just my suggestion. But what I do is I figure out what the common denominator needs to be, and I write that in my answer. So I want my common denominators to be 2a to the fourth b. And when you're dealing with exponents, remember that they just have to be, the biggest exponent will always work because you just have to add when you multiply exponents. So in other words, now I'm going to come up to this and go, okay, what do I have to multiply by to get that common denominator? And I can see that I need to multiply by a 2. And I also see I need one more a, because we know a to the third times a is a to the fourth. But we can't just multiply by something unless we make it legal by doing it to the numerator also. Because now I'm only multiplying by 1. So the bottom will be 2 a to the fourth b. But on the top, now I have, now some students I've seen like to put that in a rectangle so that they remember they inserted it into the problem. And that might be smart if you don't have multicolors. Here, look, I don't have to multiply by anything because it is the common denominator. So all I have to do is write my, that was a plus, you can't see it very good. All I have to do is write my plus sign and my 9. Now, I have 3 terms, and there's nothing that all 3 terms have that I can reduce. You can't, because remember, terms are separated by plus or minus signs, not in parentheses. So right here I have 1, 2, 3 terms, and there's nothing that can come out of all 3 terms. How about this one? Let's do 1 over x plus 5 plus 6x over x minus 5. Well now, unlike this where I just had to multiply by another a and a 2, these are a whole binomial. It's got a plus sign in it, and one's plus and one's minus. So there's no way to make them the same in my denominator. So my common denominator will be both x plus 5 and x minus 5. And then I come up to this one and go, what does it need? It needs x minus 5. I can't write that so you can see it very good. And whatever you do to the bottom, you have to do to the top, so that you're just multiplying by 1. So if you don't have multicolors, stick that in a box. It's x plus 5. Anything I do to the bottom, I have to do to the top. So now in this step, I'm going to write after I multiply. So 1 times x minus 5, sign that's hard to see, and write that. And here I have to distribute 6x through x plus 5. So I get 6x squared plus 30x, distributing 6x through x plus 5. Alright, now if there were any like terms, there is. I have an x here and a 30x here. So let's go ahead and come in order. My 6x squared first, then my 31 now, x's that I have. Factors and reduces, they will do that. So you might have to check and make sure it doesn't factor and reduce. But I think that's our answer on that. Alright, let's try this one. How about 2x over x squared minus 9 subtract 3 over x squared minus 4x plus 3. Alright, now in this problem, before you start to find the common denominator, you want it to be factored like this, like these. These are binomials, so you want to see these binomials and see if anything's in common. So begin by factoring. So I know that this one's a difference of squares. So it factors into their square roots, and the signs have to be plus and minus. That's how it canceled the middle term. Here, again, I'm telling you, factoring will haunt you. Get good at factoring. Factor, factor, factor till you're blue. I know my signs have to be the same because they have to be positive, and they have to add up to a negative. So I know that they're both subtract. Now, what I see is that they both have x minus. They have that in common, so that's clearly in our common denominator. But this one has x plus 3, and this one has x minus 3. So the only thing I can do is use all three of those binomials, x minus 3, x plus 3, and x minus 1, in my common denominator. So again, I begin by figuring out the common denominator and writing it in my answer. Now I come up to my problem and say, what does this one need in that common denominator? We can't just throw it into the bottom unless we do it to the top too. So we're just timesing by 1. What does this one need that it doesn't have? Well, it needs the x plus 3. And so at the top. And maybe if you don't have multicolor, put that in a box. Something so you remember that you're inserting it into your problem. Alright, now I have 2x times x minus 1. So I get 2x squared minus 2x. Now, be really careful here. This is huge. This is a point of errors. It's one that they'll even catch you with sometimes on test questions, because people will forget that this subtract will distribute through the whole numerator. So this is big. So it's like I have, maybe you want to write plus negative 3. So then that negative 3 makes me have negative 3x minus 9. And I cannot tell you how many people forget to make that a negative 9. Don't. And that is my final answer. Now it's possible this will factor, and then if one of the factors reduces, I could do that. But I'm pretty sure we're done in this case. Alright, let's do one more. Let's do this one because it's got 3. I want to make sure this one won't throw any of us. 3 expressions in it. And I'm going to begin by factoring so that I can see my common denominator. And then, looking at all 3 of those denominators, I can see that the smallest thing they'll all go into is this one, because I just have to multiply this by x minus 5 and this by x. So I'll begin, like always, by writing that common denominator in my answer. Then I come up to the problem and go, oh, this one needs an x, so I'll times the top and the bottom by x. This one has everything. Anything you do to the bottom, you have to do to the top. So, writing down what we have now, I have 6 times x is 6x plus, now the all-important thing where people sometimes make mistakes, if you want, change it to plus a negative 2, because you're distributing negative 2x, and now you will have positive 10. That's huge, 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 huge. Alright, so I have 6x plus x is 7x. Minus 2x is 5, negative 25. Now this looks like one where it might reduce, because I can see if I pull a 5 out, I get x minus 5, and then I have one term on the top, one term on the bottom, and x minus, so they reduce, and my final answer is the 5 over the x. That makes me wonder if these would have reduced. Those are possibly trinomials that would factor, so check those. I don't think they are, but I can't tell without a little work. Alright, you guys, good luck on 6.2.